interested in technology through Manaz and Mita. So I'm very illiterate when it comes to technology, but I guess I am learning. I have a good mentor and colleague, Manaz, that is helping me a lot, and a good friend. My presentation is a little bit, my paper is a little bit different than what you have been talking about. Most of you are working with adults and look at the influence or the value of technology in higher, I guess, higher education or school. Mine is working with young children. My focus is on whether or not computers are influential in young children's learning. As part of the teacher education, I spend a lot of time in the classrooms observing my students doing field experience or internship, and I am in centers that hardly have any computer, and I am also in centers that they have maybe 2 or 3 computers in the classroom for children to work with. There is a big controversy in early childhood education whether or not computers have any value for young children, whether or not it's appropriate for computers to be in the classroom. On one hand, there are those who argue that it has value and extends children's learning, and on the other hand, there are those who they think that it has adverse effect on children's learning. It takes place of a lot of developmentally appropriate practice for young kids. Children need to be using their senses in order to learn. They don't need to be sitting in front of the computer. But agreeing with the former one, believing that computer could have some effect on children's learning if it is used appropriately for young children, not necessarily as babysitters in the classroom or at home. That's often we see that parents or adults sitting children in front of the computer and say, just play with it so I can do my other thing. But I think it does have values. And the research that I have, I'm focusing on mathematics as part of whether or not software can be used to help children's, if I can get this to work for me. Here, okay. So for this part of the study, I'm looking at mathematics and especially on number sense. There are, mathematics covers a large knowledge, but for this particular study, I wanted it to be very specific and just see whether or not I can look at children in terms of using number sense with computer and whether or not that has an effect on the learning. We all know, as educators, that the early learning has a big impact on children's later learning. And so using mathematics as a way that they need this in order to be able to succeed in a school. And for a lot of, although we know that mathematics is very important, still in a lot of the instruction that takes place in early childhood education, and that goes from anywhere birth to 5 in kindergarten, there is actually less emphasis given to mathematics, and that's because a lot of teachers feel that they're not comfortable, or they're capable or able to teach mathematics. They all, when you talk to the preschool teachers, they all say, well, I'm not very good in math. I don't know how to teach math. There seems to be more emphasis on literacy than it is on mathematics. And non-mathematics is as important to learn number sense is as important to learn later learning as it is phonemic awareness for literacy for young children. The purpose of this study was to explore whether or not the development of number sense could be supported through integration of mathematics, computer, games in pre-kindergarten curriculum, and also to look at the teacher's scaffolding strategy, whether or not the condition in the classroom can have an effect on how children are learning. So I had 2 research questions looking at do computer, mathematics, software, games support and enhance children's learning, and under what conditions could this be influential in children's learning. For my participants, I had 62 children from a public pre-K kindergarten in North Carolina, all the children who are developing maybe at risk, or some have an IEP, that is an individualized educational plan, and also in terms of like the income, they are at the lower medium level in North Carolina. They can qualify for public pre-K, meaning that the state will pay for their school. And most of these kids have to be, they are tested and they are usually at risk for school failure in the future. So there were 62 children from 4 different classrooms that participated in the program in this study, and all the teachers volunteered. It wasn't like that I went and said randomly selected the teachers. I had to really get the teacher to wanting to participate in this activity. All the 62 children were identified at risk, as I said, and they were very multicultural in terms of like diverse their background. I had 36 male, 26 female, 32 were African American, 10 Anglo American, 14 Latino, 5 were multiracial, and all children except 7 were on free or reduced lunch, meaning that they qualify again for the public services in North Carolina. And 14 children were considered ESL. They were learning English as a second language, and 7 of the children were identified with special education needs, and usually they were requiring a speech therapy. It was mostly with language. Their average range was about 5 years for most of these kids, and this was sort of like done through the second half of the year, so they were getting ready for kindergarten. So the average age was 16 months for most of these kids, and about 62% of the children seem to have computer at home, some kind of a computer at home that they had familiarity with. And this happened through the interview with the kids and also the family that we asked on the questionnaire, whether or not they have computer at home. The 4 classrooms teacher who volunteered, then they were assigned randomly to one of the conditions that I had, and they were all female with the average of 17.5 years of teaching experience, and all the teachers were lead teacher in their classroom, and they all have to have a licensure in order to be able to teach public PE, and that is very different between the states in the U.S. Some state may not require any licensure, but North Carolina, for the teachers to work with children birth to 5, they have to have a 4-year degree with a public school setting, a private center. They have to have a degree and also licensure, so they have to be highly qualified to teach these children. The design of my study was to have an experimental research design examining the main interaction and also the main effect and also interaction between the computer software and the time which I sort of like for the intervention that I had, and I'll tell you how it was. I had 4 conditions. The 4 classrooms were randomly assigned. One was, I called it condition A, where the teacher facilitated computer play. The teacher was in the classroom to help the children while they were playing with the computer to provide scaffolding and suggestion and prompt and help as they needed. The second classroom was peer facilitated computer play, and here the children were paired either in 2 or maybe groups of 3 and work on computer software together, so they were helping each other if they needed help. I also had another classroom that the children played independently. There was no peer that would help them. The teachers were available in the classroom if they needed help in order to turn on the computer, get the software started, but they really did not provide any kind of scaffolding. And I also used one of the classroom as a control group. They did have computer in the classroom in the control group, but none of the software that we were using in the 3 classroom. So those were the 4 conditions that the children were assigned to. The computer mathematics software games, I used a total of 10 software, and these were software, the reason I chose these were like something that they were not expensive, that teachers and parents can have access to them regularly, but we did, all the teachers and myself looked at the computer software to make sure that they are developmentally appropriate. They may not necessarily be the perfect software game. There are a lot of good programs available that are expensive and requires a lot of training for teachers, but not all teachers in private centers or public pre-K have the means or the skills to be able to use those. So I was trying to look at what is available to teachers that they are using in their classroom, whether or not they can be used for the children. And some of the examples that I have of the software were like Math, Mathosaurus, Mighty Math, and Peter Rabbit. Those of you that you have children, you probably see they all come in phonics and also mathematics. And most of these focused on counting, quantity, looking at maybe sequencing, equivalences, larger, smaller, so basically on number sense. The entire experiment took about 7 weeks. I spent a week pre-testing the children, 5 weeks, then they had the software for an hour during the day during the center time. Those of you who may be familiar with the schedule in early childhood, they go in the morning, they have group time, center time, or free play time they call it, which they can have access to the computer. And all of the children were required to play with computer at some point. But it wasn't like that at the same time. So during that 1 hour, they may spend 10 or 15 minutes on the computer working on the software. And then they were tested again at the end with the same posters. I used the test of early mathematics ability, 3rd edition, to do the pre-test and post-test. It focuses on, it's a non-reference test, validated, reliable. It was developed in 1993 by Ginsberg and Brody, and it looks at the children's mathematics ability from age 3 all the way to age 11 months, and it again focuses on number sets. That's the test. All 4 classrooms were equipped with, all the 4 classrooms had 3 or 4 computers, desktop computers in their classroom. For the 3 experimental conditions, I also equipped them with 2 extra laptops, so all the children will have access to play with the computer, that they don't have to wait for their turns. Also, each experimental classroom was observed about 60 minutes each at 3 different times, at the beginning, middle, end, because I wanted to look at the teachers and children interaction, also peer-to-peer interaction, and at the time that the children were alone. So I was trying to use a little bit of a qualitative aspect to this too. All the children who are qualifying for public pre-K in North Carolina have to be tested throughout the year, and with again different kinds of tests that I was using that instrument to sort of like as a comparison and also validating what I am finding. They use the LAP 3, which is the learning accomplishment profile, and it looks at the cognitive, social, emotional, mathematics, and also the physical. So I used their score to also compare that with the score that I got on the test of math. That's all they all played the game. And for the result, I did the ANOVA, mixed ANOVA, to see whether or not there is any main effect or interaction effect. And I found that the result was that the students, there was a main effect for the groups. So it seems like the children's pre-test increased from pre to post, and also there was an interaction effect showing that some made it better than the other in terms of the condition. And that's sort of like the table shows. I had a little bit of a hard time getting the looking like I had to run a univariate or a 2-key test to see whether or not there are differences between each group from pre to post. I had to did a t-test, but I have to go back and change that. But it shows on the t-test that it seems like the condition 1, where the teacher was providing the scaffolding, those children made the most increase in terms of their math ability in the post-test as compared to the other children. So the kids also in the peer interaction made some increase in their math skills. So as the children, even in the control group, but it wasn't as significant as the first 2 conditions. This again shows the graph, where the blue line shows the post-test and the red shows the pre-test. And then you can see again in group 1, where the teacher was providing the scaffolding, children made the most increase in their ability. I also looked at, interviewed the teachers whether or not how they felt about this software, how much mathematics they're using in their classroom. I looked at their schedule and their weekly unit to see how much mathematics is included. And the result revealed that the teachers probably did say that they do not provide as much mathematics in their classroom as they focus on literacy. But somehow looking at this software, they realized that maybe I do some of these, or maybe it's not as difficult to teach mathematics. It's just that I guess I don't have the confidence myself that I feel that I can teach some of these numbers. And kids bring mathematics to a school anyway based on everyday life that they have. It's just that unfortunately we don't capitalize on the learning that they bring to school. We think that the literacy is the most important thing, and sometimes we compensate or compromise mathematics for literacy. And we all know that, especially in America, our kids don't do as well in mathematics and science as they get into high school. So there is somehow we need to focus more on early childhood on that. So from the discussions, through the discussion, I'm saying that although computer games provide individualized instruction and engage children in the learning process, and also they can provide immediate feedback and opportunities to replay the task, but maybe if there isn't someone there to help them in this process, maybe it's not as useful for the children. So for their understanding, where it's not really tapping on the ability level of the children, because what happened in the control group or in the independent, when the kids had software that was a little bit difficult, they usually abandoned the task. They couldn't figure out how to do it. Even when they were working with the peers, sometimes the other child would say, why don't you push this number, push that number? I told you, go with this one. But it wasn't really quality kind of instruction that they could provide each other. But when the teacher was available, if the child had a problem, then the teacher would say, for example, why don't you try the key that has the arrow? Look at this number. This one says 4, this one says 5. Which one do you think is bigger? Or if there were like symbols that the children didn't understand, the teacher was available to provide that scaffolding for the children. So then when they got it, they were better able to sort of like continue and finish the task on their own. So that's again shows these are children playing in pairs. Again, if it was too difficult even for the pair, sometimes they didn't have the knowledge or the skills how to really follow the game or the task on the computer, and they will abandon that. And they will just say, forget it, let's go to the block center. And as I said earlier, sort of like looking at the computer software before we introduce them to the children, it really reminded the teacher that these are some of the things I can do, that I am able. So it sort of like helped them to revise and reflect on their own teaching practices in the classroom. So from this study, I guess I could confirm that maybe computers are valuable to the learning of children if they are used appropriately and in the right context and with the right software. Not everything that is out there necessarily is good for children. And of course, how much they also spend on computers. Appropriate mathematics computer games can enhance children's knowledge of number sense, especially when it's supported by adult scaffolding or peer scaffolding. It doesn't have to be just to the adult, an older child, or even a child who's maybe more capable and skilled at the use of computer. Of course, there are a lot of limitations with this study. This was just sort of like a one-shot that I was trying to look at it. But it seems that we maybe kindergarten in the school targeted for this study, serving all at-risk children. So we could have different results. These were kids who came from a variety of socioeconomic background, kids who maybe have had some of these experiences at home, that somebody does work with them or play with them. Future research should also examine the outcomes of teachers' specific scaffolding strategy. Again, I had teachers who were very experienced and teachers who were sort of like not as much experienced, so that could have an effect on how they were providing the scaffolding and how comfortable they felt with their practice. So it would be important to find teachers who are very similar in their interaction or in their experiences, even though all of these teachers followed a very similar curriculum in the classroom. That I made sure that they are very similar in their curriculum, but they have no control over their experiences, depending on who volunteered for this study. Also, further investigation of effective scaffolding strategy will not only assist teachers, but will also help software developers to know what is important and what would be appropriate for young children to use. So, basic finding is that maybe computer software can be helpful for the young children. We could use it with young kids if it's again used